All right, welcome back, everyone. I hope your week is off to a good start. Today, we're going to be talking about abstractions, how we can abstract over our SQL and write a little bit less of it. So, first, let's start off with a little bit of review. Last time, we talked about databases. Love the formatting on that. I should have fixed that. So, last week, we talked about how we can do some fancy relationships with SQL databases and relate different tables to each other. We talked about relating data to other data in a structured manner, using foreign keys, and then three types of relationships: one-to-one, one-to-many, many-to-many. Of course, one-to-one looked a bit like this. You have two tables. You have a foreign key, user ID, for example, and the foreign key in one table just points to the ID of an entry in another table, and so it's just a one-to-one matching. There's one user for every profile, one profile for every user. Then we also looked at one-to-many relationships. For example, relating albums to songs. So we, this album Igor. Are these real albums? I've never heard of these. I wonder if they are. This album has the first two songs there, and this album has the second two songs there because each album can have multiple songs. We also talked about many-to-many, like in the example of students and courses, and what students are enrolled in what courses. We relate one student to many enrollments in what's called our join table, and then in the join table we relate the student ID to multiple course IDs, and then that relates to the course table. And of course, we can go in the other direction as well to relate one course to multiple IDs in the students table. And we can add more entries. Yeah. So SQL has a few drawbacks just in using it directly. So there's a few pain points. Your code is less readable. Susceptible to vulnerabilities is kind of iffy, and I'll talk a bit more about that later. And runtime exceptions are not handled well. You need to be very careful about handling the output that you get back from SQLite or whatever SQL server you might be using, because you really shouldn't in production use SQLite. So in terms of readability, it's pretty self-evident. I'm of the opinion that what we're looking at right now is actually kind of cool. It showcases the power of SQL, but I'll admit that what it's doing is not very obvious, and so thus it would be helpful if we had something to build this mess of SQL for us instead of having to figure it out every time. Vulnerabilities are a little interesting. So there is a common SQL vulnerability that you should know about called SQL injection, which is basically where you put a really tricky input into a login form or any other kind of form, and try and get that code to be executed as SQL in the SQL database. In my opinion, any SQL library worth anything already protects against this. It already is going to sanitize your inputs and make this impossible. And I think it's worth noting that the way you've been taught to do things using the execute method and using question marks in your SQL and then passing in a tuple of values, that automatically prevents what I'm about to demonstrate. But it's still important for you to know, I think. So, this can, once you get remote code execution, you can do so many nasty, nasty things to a server's database, which is pretty unfortunate. So let's think about a login form for a moment, right? So here's our hypothetical login form: email, password, login button. When we put an email and a password into that form, what we construct on the server is an SQL statement like this. We construct a select everything from user where email is equal to the email and password is equal to the password. So if we put in a username and an email and a password, it will substitute those in appropriately. Now, those things could be, we could find those to work or not work, and, that will log us in or not log us in. But the issue comes when you put in something like this. Now, this tricky string, if you just substitute it directly in, you'll note that there is an extra closing quotation mark in the middle of it that ends the password, and then adds an OR condition where the OR condition evaluates to true, thus retrieving all of the users from the database, even if the password, the 3x is incorrect. And then those two dashes at the end then just comment out everything else in the and end the query there, to prevent us from figuring out that something highly suspicious has happened. So a direct string substitution like this can be very dangerous. So now, even if the first two things, even if the password is wrong and the username is wrong, but the extra condition that we've snuck in is true. So now we just get that we're going to select all of the users because our where condition is just true. So this won't happen in the servers you've written. You can try this. It shouldn't work. The SQLite 3 library, when you use the question marks and the tuple, automatically, let's go back a second, it will automatically sanitize your input, which means quotation marks will be escaped with a backslash when they're passed in. You may have encountered escape sequences in some of your other programming classes. And it will go through, and all of the special characters, it will escape so that they can't affect it. If you do this on the servers that you've written, it will check if the password is equal to that string, including the spaces, including the quotation marks, and it presumably won't be. This is a bit of a cautionary tale, really, to never do direct string substitution into an SQL query, because that is what allows for injection attacks. As long as you do something, and again, any SQL library worth anything, in my opinion at least, will provide facilities or most likely automatically escape all inputs. But if you do something to escape the inputs, you are fine. This is, in modern times, a solved problem. But regardless, let's look at object relational mappings. So in an object relational mapping, the objects are this kind of abstraction where you create objects in your code, and it will sort of under the surface automatically translate the operations you do in code to SQL and keep your database updated, so you can have persistent storage. So this can sometimes make your code a bit easier to reason about, because your entities are you can more directly interact with your entities instead of having to construct these queries whenever you want to modify them or anything like that. So, for example, in SQL, where we would define this table with an ORM we would define a class with the same three fields that we would define to be columns of certain types. So in this class, we're going to use SQL Alchemy, or SQL Alchemy if you prefer, which is a pretty popular ORM for Python. It has a lot of built-in query patterns, and it integrates really well with Flask. Although in my opinion, most things integrate really well with Flask. Flask is pretty hands-off and lets you do what you want. So there's several benefits to object relational mappings. So I think it's worth noting before these next two slides that a lot of app dev is in the pocket of big ORM, so to speak. I am a little less pro ORM than they are, but I think that they are very useful still. So obviously, when we're working directly with classes, and that's automatically being translated into SQL, it just makes it a lot simpler to reason about, easier to read. You know, instead of constructing some big long string, we just do some basic operations on the object we've defined, and it more closely resembles what we're thinking about when we're doing it. You really don't need to write any SQL. So if you don't like it, good news. You don't really need to deal with it. Then this keeps all of your logic in Python. So, or in whatever language you happen to be using more generally, in this class in Python. So you no longer need to decide, what parts of the logic are going in SQL and what parts are going in your Python. You're writing it all in Python, and ORM is, turning what needs to be turned into SQL into SQL. A lot of ORMs also offer you the ability to choose your database backend. So, right now, you've been directly using SQLite. With SQL Alchemy, for example, you could choose for it to be SQLite, or you could hook it up to a Postgres or a MySQL database, and it would port pretty much seamlessly. You don't need to change because there's little quirks about the different databases, but the ORMs generally handle all of that for you, which is really nice. Secure against SQL vulnerabilities, again, it is, but this is also true of any direct SQL library worth anything, in my opinion at least. I would count this as true, but not particularly an explicit benefit. There are some drawbacks. It's slower, especially in a language like Python. In some compiled languages, you can get a lot more performance by doing a lot of the work of generating SQL at compile time. But this is going to be slower. You've got, whenever you do something, there's more Python running in the background to convert it into SQL. Sometimes the generation isn't all that great. On a certain app dev app recently, we did have a problem on the back end where a certain combination of joins was causing really inefficient SQL to be generated, and it was completely using up the server RAM for this query and crashing it. This was not with SQLite. I believe our theory at the moment is that SQLite does not have this problem. But sometimes ORMs have little quirks, inefficiencies, certain operations, certain edge cases that they don't handle that well, where you might run into just completely tanked performance. These are rare, and these are for big, complicated use cases, but it's something to be aware of. It also increases your application code. There's more boilerplate you have to write. You have to set up classes for all your entities. You have to connect everything properly. It is a bit of boilerplate to get up and going. It abstracts away the fundamentals of SQL. Personally, I enjoy SQL. I've written a lot of SQL just directly myself, and I really like it. I think that if you really like knowing what's going on and controlling what's going on, like I do, ORMs may be slightly annoying to you. And again, because they're too abstract and you aren't always completely sure what's going on, sometimes you might do something that's just really not great. You just misuse the library because you don't really know what's happening. You're not really sure. You're like, I think this will work, and then it does, and then somewhere down the line it comes back to bite you. That said, we're going to make you use ORMs. The benefits are very good. The drawbacks are drawbacks. Ultimately, we will leave it to you to make your judgment about what you think is the best method that you would like to use for backends in the long run. But for now, we're gonna use some RMs. It'll be fun. So yeah, that is it for this week. I hope you've enjoyed this lecture. Please feel free to come to office hours, reach out on Slack if you have any questions. And remember to have fun on this week's assignment. I'll see you next week.